All right, guys, we're moving on to 10.7a, which is area of circles, and pretty easy mission today. I can find the area of a circle, and we really need to go back to area that we've looked at for previous figures. And again, if I'm talking about a rectangle, for example, again, we'll just kind of make sure that you know that this is a rectangle. Then I would very simply just do area equals base times height, right? And even if we were talking about triangles, you remember that when we talking about triangles, that we still kind of use this same formula. The only difference is it's actually half of a square. So area of a triangle equals half the base times the height. So if only we could use either this formula or this one to help us with an actual circle, then maybe we could develop this just a little bit further. And of course, we've talked about circumference as well. So maybe pi is going to come in there as well. I don't know. So let's talk about a circle here for just a second. And I want to just show you kind of where the formula is derived from. And this is really, again, circles are very interesting. They're fascinating, as a matter of fact. So let's say if we take a circle like this, and I need to find this area. So I need to find the space again. Area is the space that it occupies. And so if I need to find this area, it's going to be difficult because I don't have just a square or even a triangle. Again, it's half of a square. So I don't really have any squares or even any sides in a triangle by a circle by definition is not a polygon because it doesn't have any sides. But what I can do, and if any of you have eat out, which I'm sure you have, and you've eaten a pizza before, and you recognize that pizzas, generally speaking, have about 8 slices, and they usually look about like this. Like one slice is really, really small, and one slice is pretty big. Obviously, they should be the same, but you get the general idea about a circle, right? I can divide it into what almost looks like little triangles, okay? What I want you to recognize and realize is that I can deconstruct this, okay? And this is one of the things that we do with composite figures to try to figure out the area of composite figures is to deconstruct these. In other words, I could pull these pieces out and maybe rearrange them. And so if you think about this, I could actually rearrange this this circle in kind of this manner. Okay, and you kind of get the idea. And what you see here as a general shape, and I'll just kind of outline the general shape that you're seeing here, is you are seeing the makings of a parallelogram. Okay, you actually can kind of make a parallelogram out of this. Now remember, the area of a parallelogram is exactly the same thing. It's the base times the height, right? Again, we're talking about, but we need the vertical height, and so I would need to know what this here is. Well, let's just think about what that really is. If I think about it in the context of my circle, really what I'm talking about is I'm talking about the radius. Okay, the radius is really the height here. So let's go ahead and put an R out here for the radius. Okay. And then again, what you might realize is if I were to extend this all the way out, okay, I had actually 8 pieces here. So if I were to extend that all the way out to these 8 pieces that I have here, then what you would recognize here is that these actually, and I'm going to make these a different color. Let's see. Let's go with red on this. Really, my length is kind of like this. Okay, well, what is that? Well, it's exactly half. Okay, it's half of their circumference, right? It's half of their circumference. And remember, if I'm talking about circumference in relation to radius, because really what I have here is I have this much, right? I have this much of circle that is represented with this red part. So I have 1/2, and remember that the formula for the circumference of a circle using radius is 2 pi r, right? So if you think about when I take area equals base times height here, what I really have is I have area equals 1/2 of 2 pi r times h, or times r, sorry, which is my height. Okay, so let's think about what happens here. area equals, well, what's 1/2 of 2? Well, 1/2 of 2 is just 1, so that really just kind of goes away. So really what I have is pi r times r. But I could simplify that even more because r times r, remember that's the same thing as r to the first times r to the first. And when I multiply exponents, I actually add those exponents. So I end up, ladies and gentlemen, with a formula of area equals pi r squared. Now, I don't know about you, but every pie I've ever eaten has been round just like this one, okay? But when we're dealing with mathematics, I want you to understand that to find the area of a circle, it is literally pi r squared, okay? So there's your formula that we're going to be using for this. And actually, this is going to be a pretty easy task. You're only going to have about 3 different types of problems that you're going to be given. So let me go ahead and give you the first example here. Say we have a circle, and I'm given this, and I'm told that this is 6 yards, okay? So think about it. What am I given here? I am given the radius. And so given the radius, I have everything that I need with my formula to be able to go. That's really all I need in this because pi is just a standard. R is there and then squared, okay? So my area here would be pi times 6 squared. And finalizing that math would be 36 pi yards, okay? Now remember, pi yards what? I'm talking about area. So that means that this answer is going to be squared, okay? When I'm talking about circumference, I don't square it because I'm not finding an area. But in this case, I am finding the area of this circle. So this circle would be 36 pi yards squared, okay? All right, so let's look at number 2. We'll call it number 2. And in this case, we're given another circle. Again, I'm trying to draw these quick, and it's not really working out real well, but I want you to understand that that is a diameter of 16 centimeters. Now, again, my formula is area equals pi r squared. So I need to be able to get to the radius. Well, remember the radius is exactly half, right? Half of the diameter. And so half of 16 would be 8, which means that I would have pi times 8 squared. And 8 squared is 64 pi centimeters squared, okay? So in this case, I was given the diameter. In this case, I was given the radius. What if I am given the circumference? What if I am given the circumference and I'm asked to try to find everything else? Well, let's just see how this could work out. So in other words, let's say we had another circle, and they're telling me that the circumference equals 25.8 meters, okay? Remember, circumference is the distance around the circle. And so again, think about the fact that, well, what do I need? What do I have and what do I need to get to? Well, I need to find the area, right? Area is pi r squared. So in other words, in order to do this, I have to get this to radius. Well, the first thing I want you to think about is the formula that actually helps us to get the circumference of a circle using radius. So circumference using radius is circumference equals 2 pi r, if you remember from yesterday and the day before. So now let's take what we're given and let's go ahead and substitute it in. We're told that the circumference, they give us that, is 25.8. So we can go ahead and put that right here. 25.8 equals 2 pi r. Now the r is what I don't know, okay? So this actually needs to become isolated by itself. Well, remember, there's always multiplication between all of these things, right? Which means that I could go ahead and divide by 2 pi on both sides. And if I divide both sides by 2 pi, then that will tell me what my radius actually is, because all of these things on this side are going to cancel out when I do my equation. So let's go ahead and do that math and see what happens. See, we have 25.8 divided by 2, and then divide that by 3.14 for pi. And let's see. We should come up to 4.1. We're just going to kind of round that out. And now I have what I need to put into my formula, right? Area equals pi r squared So area equals pi times 4.1 squared. And let's see, 4.1 times 4.1 equals 16.81 pi. Okay. And if we needed to take that all the way out, right? If we need to take that all the way out, we could go ahead and do that times 3.14. And basically, we're going to come up with 52.8. If we're going ahead and rounding that to the nearest one's unit would be 53 meters squared. Okay. So again, you have to take what they're giving you, this circumference. You're plugging that into the formula for circumference using area to find out what this area right here is. Once you find the radius, once you find that radius, then substitute that back in to your area formula so that you can figure out what those actual numbers should be. Okay. All right. So that should pretty well do it. Again, this is the type of questions you're going to have. Should be pretty straightforward, especially if you're given the radius. All you have to do is just literally plug that into the formula. If you're given diameter, just divide it by 2 because the radius is half the diameter. And then these are probably going to be the trickier ones, the ones that you're given circumference. And you've actually got to figure out then what the area is. I can tell you, though, this is the kind of stuff that you're going to see on the ACT. They will have at least 2 or 3 of these questions out of 60 on an ACT test that have to do with circles or circumference or radius or diameter, one of the 3. Okay. So if you need any help, make sure that you reach out to us and we'd be glad to try to help you.